Alright, today's lesson is about polynomials and linear factors. Really, we're tying some things together we've done before. So here's a little example, something you might run into. Write in standard form. Remember, standard form from previous lesson is just the polynomial in descending order, highest degree to smallest degree. So really, they're asking us to multiply this thing out, okay? So not hard to do, just got to be kind of careful going through things. So I'm going to go ahead and multiply these two things first, just kind of show you here. In fact, I'm going to write it over here. So x minus 3 times, well, if we multiply these together, I'm going to get x squared, let's see, 2x minus 5x, that'd be minus 3x, and then minus 10. So you just do it in pieces. Now I'm going to take these all the way through. So I'm going to take x through everything. So x cubed minus 3x squared minus 10x. Okay, again, I took the x through everything. Now I take the negative 3 through everything. Minus 3x squared plus 9x. Okay, just be real careful, watch your signs, plus 30. And now combine like terms, okay? So x cubed looks like the only cubed term. So I'm going to just underline them so I know I've looked at them. Minus 3x squared, so that's minus 6x squared, so I took care of those guys. Negative 10x plus 9x, so that's minus x. So we got those, and then our constant term, plus 30. So there is that polynomial in standard form. Again, just multiply it out, okay? What if they give us something like this? Identify any relative maxes or mins of the function. If they give you a graph, we'll just look at it. Look at the highest value you can see, that would be a relative max. Look at the lowest value you can see in a curve, that would be a min, okay? This one, actually, let's just go graph it. So let me bring up Desmos, and I've already typed it in just to save time for this video. So here's the graph, and again, I can make it a little bit bigger here, maybe we can see it. Click on the graph and it shows. Now I'm looking, when I'm talking maxes and mins, I'm looking at y values, okay? So here is a max. Let's just round it to one decimal, so about 2.1. Let me write this over here. So a max of about 2.1 and a min of about, let's go down here, notice relative min where it dips, negative 0.6. So negative 0.6. So again, if they give you a polynomial, just go graph it in Desmos, click on the graph, boom, it'll show you maxes and mins. Really nice. Notice also something while we're on this, there's the x-intercepts as well. Those are the zeros of the polynomial. So that's really convenient as well. Alright, let me get rid of my graph. Let's go look at another thing. Find the zeros of each polynomial. Find the zeros of each polynomial. So you've done this before, right? Same thing as solving polynomials. Well, this one's nice. It's already factored. So anything you plugged in here that would make one of these 0 is a 0 or a factor of the polynomial. And so x could be 7, because if I put 7 right here, that would be 0. It could be 5. Put 5 right there, it would be 0. Or it could be 3. So again, if they say find the zeros and they give you factored form, super, super easy to do that. How about this one? They want us to factor it and find the zeros, or solve the polynomial. Very similar to what we've done before. Notice it's cubed, don't be intimidated. Oh, there's an x in common, so let's pull that x out. So x times x squared plus x minus 12. Now this guy will factor. If it didn't, by the way, you could complete the square or use a quadratic formula if we needed to, but it'll factor. So we want factors of negative 12, add to make 1. Hey, 4 and negative 3, we'll do that. So x times x plus 4 times x minus 3. Again, 4 times negative 3 is negative 12. 4 minus 3 is positive 1. Now it's in factored form. It's just like this problem, right? So x could be 0 from this guy. It could be negative 4, or it could be positive 3. Hey, there you go. It's just like solving, right? It's just another way to say it. Find the zeros. How about something like this? Write a polynomial with the given zeros. Okay, so they give us 3 zeros. They want it in factored form as well as standard form. Factored as well as standard. So if these are the zeros, it's just working backwards. So y equals, well, if negative 5 is a 0, x plus 5 would be a factor, wouldn't it? Because if I put negative 5 right here, this would equal 0. 1, so that would be x minus 1, and x minus 2. So again, it's just working backwards. We just did, hey, if this is a polynomial, what are the zeros? Now the zeros, what is the polynomial? Now for b, when they want it in standard form, we're going back to that first example we did today. They just want us to multiply this out. Okay, so let's just do that quick again to kind of review. So let's multiply this. So I've got x plus 5 times, we're going to multiply these two together, x squared, negative x minus 2x, so minus 3x plus 2. And again, now multiply everything through, so let's take our x through. I'll do it below here. X cubed minus 3x squared plus 2x. Now take a 5 through everything, so plus 5x squared minus 15x plus 10. Again, just kind of keeping track of everything, make sure we do the x through everything, the 5 through everything. Now combine like terms, so x cubed, got that guy, negative 3x squared plus 5x squared, that's 2x squared, so we got that. 2x minus 15x minus 13x, and our constant term is left plus 10. So this, and again I could do y equals here. This polynomial is the same as this. This one just happens to be factored. Okay. One last thing for our lesson today. Sometimes polynomials have factors that repeat. Okay, so we can describe that using this term multiplicity. So it may be a little problem to illustrate. Find the zeros, which we've been doing. State any multiplicity. Notice I can factor an x out, so let's do that. X times x squared plus 10x plus 25. Oh, that'll factor. It's a nice perfect square. Factors of 25 add to make 10. 5 and 5. So x times x plus 5 times x plus 5 if I factor that. Notice, here's what we're talking about. X plus 5 repeats. So we could say our zeros are x equals 0 and negative 5 multiplicity 2, because that one repeats twice. Okay? Hey, not too bad. Little lesson. Going to multiply some stuff out, factor really a lot of things we've been doing. We're just saying now let's find the zeros instead of solve the equation.